we've taken a lot of equipment from Sonodyne and we put it on board the boat, put some of it on the seabed, and we're using it to position the divers. We're positioning the structures on the seabed, basically anything that goes over the side, and working out where it needs to be. We've got two systems on board that are in constant use. The main system is going to be this system that I'm running here, which is currently positioning something that's just sat on the seabed. It's on the frame and it's being used to look at what's going on in the mud. Well, this leads us to another positioning system we have on board, a more accurate system than the one that's actually mounted on the vessel. For this we've had to deploy 4 transponders on the seabed in frames. Those went in around the hull hole and were then subsequently positioned and are then used as position references for the survey. The system itself acts like an underwater global positioning system, and the beacons we put on the seabed act very much like satellites in space used for GPS. Here an acoustic interrogation from the ROV. It goes out into the water. This is just a sound pulse. The beacons then listen to the signal in the water and reply. The time taken for the signals to go out and back is measured. Those measurements we can use to work out where the ROV is underwater. We do the same thing in this environment with divers carrying an acoustic transceiver mounted on a pole known as Mr. Sticky. Take a fix on an object on the seabed.
Yeah.
Place it on
top or the
point
side.
you position up, and then check the bubble gauge here.
Yeah.
And make sure
In the centre.
that it's upright. Bubble in the centre.
Same as survey on land.
Same as survey on land. This is your underwater survey stick.
Yeah.
So what I need you to do is to hold the stick upright, keep the bubble as much in the centre as you can. There you go, around about there. And if we zoom in, see the Isle of Wight gets bigger, and then suddenly we start to see more information about the area we're in. Here's Southampton, here's Portsmouth, and here we start to see buoys and shipwrecks and other things that are associated in the area, along with contour lines and depths of the seabed. Zooming in further, we start to see the dredge channel, proposed channel, and then the extents of the site. And then around about our targets of other objects that we're investigating, things that have been picked up by previous surveys. And here we have some very high accuracy depth information that came from multi-beam sonar. And then we start to see the hole where the hull was removed from. Zooming in further, we can see a mock-up of where the hull actually was, along with trenches from previous excavations, and the frame that was been deployed in 2004. Further on in, we've got cargo baskets and manifolds used for the airlifts. We've got sample points here, some samples that have been taken on the seabed, other targets, and this large object here, which is the big front tin. We've got trenches from 1975 to 2004. So all the areas that have been worked should appear on here. Anywhere that's not covered by a trench, in theory, could contain artifacts, structure, or whatever. So if we come back to the area that's being worked this year, the area that's primarily inside this frame, half of the area, in theory, has been worked before. There's been a trench, T1, was put in there many years ago. Some of the area here is virgin ground, could contain structure. This area on this side of the frame does contain structure and hasn't been worked. If the excavation moves this way, definitely moving into an area that's not been looked at before. And looking at the outline of the hull, which is this dotted line here, this is the position of the hull, or the bow section. If the bow section had collapsed onto the seabed, in theory, then this is the area of the highest probability of finding the bow.